before, we did a lot of factoring at the beginning of the year. So we're going to be using that factoring. You did factoring and solving the quadratics back in Algebra 2. So today's portion should be all review, but it's important enough that we're still going to take a day going over it because you have to have it for everything moving forward. So when I talk about a quadratic equation, what is a quadratic? What does it have in it? S squared, x squared. Okay, to solve a quadratic, we are going to use what is called the zero factor problem. It says if a and b are complex numbers and a times b equals 0, then either a equals 0 or b equals 0. Okay, in other words, if you're going to multiply and get 0 for an answer, one of the things you multiplied by had to be 0 to begin with. This only works for 0. Now, if I say like 5 times x, or let's just do this. Let's say I said x times y equals 0. Either x or y had to be 0. But if I said x times y equals 4, do one of those numbers have to equal 4? No, it could, but they could both be 2. They could be 1/4 and 16. So it only works if it's equal to 0. So that'll be the key thing with any quadratic. The first step will be to set it equal to 0, and then we'll solve from there. So let's look at a problem. Alright, so first step, every time it's a quadratic, we want to set it equal to 0. We prefer for the x squared to be positive when we get ready for factoring purposes, so I am going to move everything to the left-hand side of the equation. So that means I have to add over my x and subtract over my 12. Alright, so then what do I need to do to solve this? Somebody knows. Box method. We need to factor it. So it is a 1x squared, so we can do our shortcut factor. Alright, so then x squared would break into x. Two numbers multiply to -12 and add to +1. So set it equal to 0. Factor. Now at this point, we just need to solve it. So we have two things multiplied that equal 0. That means one of those things had to be 0 to begin with. So I'm going to say either x minus 3 equals 0 or x plus 4 equals 0. So that means x would be 3, or if you subtract 4, -4. How many answers should you get on every quadratic? 2. It's an x squared, so we are going to get 2 answers every time. What if, in terms of a graph, what do the 3 and the -4 represent? The x-intercepts, where you touch the x-axis. So eventually we are going to talk more about the graphs and talking about inequalities with these, but if you were to graph this, the 3 and the -4 are the 2 x-intercepts of that graph. Alright, let's look at B. What do I need to do here? It's already equal to 0, so I don't have to do that. Factoring, can I do box method on this? no, I don't have 3 terms. What can you do? You don't even have to do a difference of squares because 9x is in a square. If it were just x squared minus 9, we would do difference of squares. Take out an x. Greatest common factor is always our first step for factoring. So then you just set each one to 0. So either x equals 0 or x minus 9 equals 0. So the 2 answers we get are 0 and 9. It is possible to get the same answer twice. When you have a repeated solution, that is called a multiplicity. So we will be seeing that term starting in this section and moving on through the whole next chapter. It'll come up. So a multiplicity is just a repeated solution. So it would be like when you solved it and you got 3 for both of your answers for x. Let's look at Alright, so first step here, it's already equal to 0. It's a 1x squared, so we can do our shortcut. What number is multiply to 9 and add to negative 6? Okay, if you say each of those is 0, they're the same thing. You're just going to get x minus 3 equals 0, so x equals 3. But it comes up twice for both parentheses. So what I want you to put is 3, a lowercase m, and a 2. That's 3 multiplicity 2. That means 3 is a solution 2 times. In terms of a graph, when we get there, we'll talk about this one has an x-intercept of 3, and that's the only x-intercept, so it would be a graph like this. It just touches the x-axis there and bounces off. Okay, D. What do I need to do here? Get everything on one side. So I'm going to subtract over this 12x, and I'll go ahead and put it in decreasing order. So 4x squared minus 12x plus 9. Okay, so when I look at that, am I going to be able to just do the shortcut on it? No, you'll need your full box method. So I'm going to multiply those, and multiply to give me 36, and they need to add to give us negative 12. What would that be? So then, if you factor, you get 2x minus 3 and 2x minus 3. So to solve it, set each one to 0, so really you just have to do one of them because they're the same. So add your 3. Divide by 2, and we get 3 halves, but it works for both parentheses, so what else do I need with this? Multiplicity 2. don't you guys do a couple? So the first one made me really happy. Everybody was doing this right. You will not believe when it comes time for a test or quiz how many people will just set each part equal to 4 right here. But it doesn't work. You have to go ahead and distribute. You need 10x squared plus 3x, and I'm going to subtract over my 4 because you have to get it equal to 0. So then we need our box method. So these things multiply to a negative 40 and add up to a positive 3. What's that going to be? Yep, 8 and negative 5. So we get 5x and 4. This way you get 2x minus 1. So set each to 0. And you get negative 4/5 and positive 1/2. Is that one okay?
Exactly how you said. Most people do.
Okay, second one, we do our box method. So those multiply to 36, add to 12, so that would be 6 and 6. So if you factor, you get 6x and 1, 6x and 1. So you can write it twice, you can just put it once squared, it doesn't matter. So when you set it equal to 0, you get negative 1/6. It came up twice, so multiplicity 2. Last one. Did anybody divide by x here? Good. So set it equal to 0. Subtract over your 14x. Then you can factor out a 7x. So set each one to 0. And you get 0 and 2 7s. Any issues with these? So bringing back in all of our factoring stuff from earlier in the year. Only difference is now you have to go ahead and solve it. Set each parenthesis to 0. Last part I want to talk about today. What if I gave you a problem like this? How many x's do you have? Right, we have our x squared right there. Do you have an x to the first term? No. If I just wanted to get x by itself, how would you get rid of the square? Square root. If you add a square root into a problem, what else do you have to add? Plus and minus. So the square root of x squared would just give me x equals plus or minus. We can't break down the square root of 5, so that's our final answer. Now this only works when you have all of your x's in one spot. For instance, if it had been x squared equals 5x, could you add the square root there? No, because you have x's here and here. But if the x squared is isolated, then you can solve for it with a radical. It's called the square root method. Alright, let's look at this one. We have a couple options for solving it. We could go through and start multiplying everything out. We could also, if I want to get rid of this 3, what would you do? Divide by 3. So if I divide each side by 3, those would cancel. So I get x minus 2 squared. 48 divided by 3 is 16. So you could multiply this all out, or you could realize, okay, the only place I have x's in this problem is right here. So if I want to get those x's by themselves, what would I do? Square root. If you add a square root, you need plus and minus. So I get x minus 2 equals plus and minus. The square root of 16 is 4. You want to be very, very careful here. What I see a lot is people add over their 2 and they say, okay, x is plus or minus 6. And that's wrong. What this means, if you were to add your 2 over, you have 2 plus or minus 4. So 2 plus 4 is 6. But 2 minus 4 is negative 2. Okay, the other option, if you don't like it that way, you could actually make 2 equations. This means x minus 2 equals positive 4, x minus 2 equals negative 4. And solve each. Add your 2. So you get your 6 and your negative 2. Questions right there? Mm-hmm.
Couldn't you FOIL that out and reduce it?
Yes. So the other option, you could, from here or the beginning, go ahead and multiply it all out, set it equal to 0, and factor like the other problems, and then do the same thing. Alright, I want you guys to try a couple. Here are your problems. You could write this twice, multiply it out, set it equal to 0, or you could add your square root and plus or minus. So x minus 1 equals plus or minus the square root of 4 is 2. If you add your 1, it's like 2 different problems. 1 plus 2 is 3, 1 minus 2 is negative 1. So you get 3 and negative 1 for that. Second one, if you add your square root and your plus or minus, it's the square root of a negative 49, so that would be 7i. Last problem, I just want to mention something. What if I gave you let's say negative 20. This problem. What would I need to do first? Square root. With that comes a plus and minus. So I get 3x plus 4 equals plus and minus. Okay, 28, is that a perfect square? No, so you have to reduce it. What does it break into? So square root of 4 is 2. It was a negative, so I, so 2i radical 7. Now what would you do? Subtract 4. Where is that going to go? If I put it here, can you actually add it with the 2? No, because they are not like terms. So you just have to leave it like this. Then what would we do? So negative 4 over 3 plus or minus 2i radical 7 over 3. So it is possible to get some uglier answers when you're doing this. We saw some problems like this back when we were doing the imaginary numbers. We had some on our quiz that you had to be able to break down those radicals and remember to pull out your i's. So you can only add together if they're like terms. Any questions for me?